Hello everybody, I will start my today's another coding practice. So in this video, I will talk about this question. Pick index in a mountain array. Let me get started. So in this question, I will be given an integer mountain array of length n where the values increase to a peak element and then decrease. Return the index of the peak element. Your task is to solve it in O of log n time complexity. Return the index of the peak element. So I will be given the integer array, then I will return the index of the peak element. So for example, I will be given something like this, and then I will return the index of this. So it should be index 4, no, index 3. So that's my task, and let me confirm the input of this question. So in this question, I will be given the array. So array is the input, and I will return the index. So integer should be the output. And one thing I'd like to confirm is that if this, array, so question number 1, and it includes the same, element multiple times or not. That's what I'd like to confirm first. Also, I'd like to confirm if the array can start from peak, or if the array can end with peak. That's one thing I'd like to confirm. Yeah. So let me take a look. So it seems like the same element can be included, maybe. No, because increase, it says increase, not non-decreasing. I can say this is not possible. And also from this, constraint, it says mountain array. And so I can assume that there is at least one element smaller than the peak element. And also there is at least one element which is, on the right hand side of the peak element. So that's where I can assume from this question statement. Okay, so that being said, let me think of the algorithm. So what I can say from this array is that firstly, the first element is not the peak element. So I can find the element from index 1 to index n minus 2, assuming that the number of the element in the mountain is n. And also here, what I can say is I will compare the element with the right adjacent element. And I will think if the element is larger than the right adjacent element. So for this, it's false. This false. Then this is true because 5 is larger than 4, which is the right adjacent element. And then this one true. Yeah. After the peak element, the numbers are decreasing. So that being said, I can say that my task is find the first index which meets this. So this is my task. And for that, I can use the binary search. And what I can say is, for example, I will start from low here and high here. Then every time I will take the middle index, and if it is true, that can be answer. I mean, the index I'm looking for is that middle index, or it can be on the left hand side of that index, that middle index. And in the case, if the middle index doesn't meet this condition, the index I'm looking for is strictly right hand side of the middle index. So in that way, I can narrow down the scope I'm looking for half by half every time. So in this way, I can find the index, peak element index in log n time. Basically, I can say I will use the binary search. Okay, so let me start the implementation. So as I said, low should start from index 1 and high should start from index, n minus 1 minus 1 n minus 2. And it is guaranteed that there is at least one peak element and exactly one element, peak element. So I will say, I will narrow down the scope. And if low is equal to high, I can immediately say it's the peak index. So from here, I will implement the typical binary search. Binary search. If this is still false, no, or yeah, it's true. Okay. If it is smaller, then low is middle plus 1. And otherwise, yeah, because array middle and array middle plus 1 element can be the same. So in this else statement, this is a case where middle is larger than the middle plus 1 number. In that case, I can say this. So this is true. So the index I'm looking for is this element or smaller element. High is middle. Okay. So now here, I can say it always satisfies that this. And I can return low index. Okay, I think this is good enough. So now let me walk through my code with this quite simple example. So in this case, low start is, oh, this is too small. So let me say this. So in this case, low begins with index 1 and high begins with index 4 minus 2 is 2. So this is it. And while high is higher than low, this is true for now. So middle is 1 plus 2 divided by 2 is 1.5. So it should be 1. Middle is now here. Then I will see if array middle is array middle plus 1. So this is true. So now low is middle plus 1. Low is not here. And high is still here. Then I will go back to line 32. And I can say now low is equal to middle. So low isn't smaller than high. I go out of the while loop and I go to line 39. and this is true now. And also line 40, yeah, this is also true. So now I return the index. This is correct. So I'm pretty sure of my code. Run me execute. Then I will submit. Okay, so it now accepted. So I will quickly wrap up this video with, walking through, summarizing the question solution. So in this question, I will, I'm given the array of mountain array. So at some point, until at some point, numbers are increasing, strictly increasing. And then from that peak number, numbers are strictly decreasing. And that being given, I will find our index of the peak. So, yep, what I did as a solution algorithm is using the binary search. So every time I pick up the middle number of the search, I mean, and then I will see if that is a peak number or not. And if the so for that, I will take a look at the right adjacent number. And if right adjacent number is larger, then the peak should be on the left hand side. But if the right adjacent number is smaller, then that middle index can be the peak number, or the peak number is on the left hand side of that. So in that way, I can narrow the scope half by half, and I can find the peak index in the end. Okay, so let me finish my solution. This video with this. Thank you so much. Bye.